Today, we are surrounded by screens, LED lamps, and giant light panels. But not so long ago, blue light was considered impossible. For decades, the world's largest corporations worked on it and failed. Then one engineer appeared from a small Japanese company and did what thousands of specialists could not. This is the story of Shuji Nakamura and the most stubborn LED ever created. In 1962, General Electric engineer Nichia demonstrated the first visible spectrum LED. It emitted a dim red light and looked more like a technical curiosity than the beginning of a lighting revolution. In the following years, yellow and green LEDs appeared. They were reliable, durable, and efficient, but had one fundamental limitation. They could not replace ordinary light. Without blue, it is impossible to create white light. And without white light, there is no real lighting, no displays, and no full-color screens. For decades, LEDs remained where brightness and color were not critical. Calculators, digital clocks, instrument panels, and power indicators. By the late 1970s, it became clear if humanity wanted LEDs for lighting and displays, a blue LED was essential. It was the key to everything. Creating a blue LED turned out to be far more difficult than red or green. The reason lay in physics. Blue light requires a wide bandgap semiconductor. That means higher energies, extremely strict crystal quality, and almost zero allowable defects. From the 1960 seconds to the 1980 seconds, the world's largest companies worked on this problem. IBM, Bell Labs, General Electric, Sony, Toshiba, Panasonic. Thousands of engineers, hundreds of millions of dollars, and almost no results. Laboratory samples did appear, but they were too weak, too unstable, or far too expensive for mass production. Gradually, the industry came to believe that LEDs would never become a true lighting source. Their future was seen as indicators and decoration. Many executives believed incandescent and fluorescent lamps would remain unbeatable. At the same time in Japan, an engineer named Shuji Nakamura was working at a small chemical company called Nichia, which produced phosphors and simple LEDs. Nichia was not a technology giant. It had no massive laboratories, no armies of researchers, and no excess funding. By the late 1980 seconds, the LED market was saturated, competition was increasing, and the future looked uncertain. Nakamura had no doctoral degree, did not publish in elite journals, and was not part of the academic world. In fact, he often built his own laboratory equipment because the company could not afford expensive systems. Yet it was he who proposed an idea that sounded almost insane: to create a blue LED that the world's largest corporations had failed to achieve. Nichia's management hesitated. Blue LEDs were considered a dead end. But in the end, the company took the risk and allocated Nakamura a large budget by their standards, hundreds of millions of yen. Nakamura understood one thing: to get blue light, you need an almost perfect crystal. Any defect turns light into heat. So the first challenge was learning how to grow exceptionally high-quality semiconductors. He went to the United States and mastered MOCVD technology, metal organic chemical vapor deposition. It was a complex, delicate process, more like an art than an industrial technology. When Nakamura returned to Japan, he didn't just copy what he saw. He redesigned the reactor itself. Most systems at the time used a single gas flow. Nakamura added a second one, carefully calculating geometry and flow velocity to keep the flow laminar, without vortices, without turbulence. This decision went against conventional wisdom. It was believed that a second flow would only worsen crystal quality. But the result was the opposite. In the winter of 1990, Nakamura obtained a gallium nitride GaN crystal with electron mobility several times higher than anything achieved before. It was the first real breakthrough. But a high-quality crystal was not enough. To make an LED, a PN junction was required, meaning P-type semiconductor material. With gallium nitride, this was considered nearly impossible. Magnesium dopants were blocked by hydrogen, and the material did not work. Earlier, Japanese researchers Isamu Akasaki and Hiroshi Amano had shown that P-type material could be achieved using electron irradiation. But this method was too slow and too expensive for mass production. Nakamura found a simple and brilliant solution: thermal annealing, heating the material to high temperatures, broke the bonds between magnesium and hydrogen, and freed the p-type semiconductor. In 1993, Nichia introduced the first commercially viable blue LED. It was bright, stable, and relatively inexpensive. This instantly changed the industry. White LEDs became possible. The LED lighting revolution began. Thin displays and light panels emerged. By the mid-1990 seconds, blue LEDs were already used in electronics, displays, and early lighting systems. What was once considered impossible became the new normal. Shuji Nakamura did not force the industry to accept his ideas. He simply created a technology that worked so well, it could not be ignored. In 2014, this work was awarded the Nobel Prize in Physics, shared by Shuji Nakamura, Isamu Akasaki, and Hiroshi Amano, for the creation of the efficient blue LED. And from that moment on, light ceased to be a side effect of heated wire and became a precisely controlled result of quantum physics. Light stopped being a byproduct of heat and became a predictable quantum process that humanity learned to control.